All right, let's go through this one. I thought it was going to be the last stats question, the last one. As it turns out, we've got one more, which is this one. It's the perms and coms. So if you have a look at the screen, we've got statistics, which I've also written down on the board. These are the letters, and you're going to choose 3 letters and you're not going to replace them, basically. Okay. So I'm just going to make a 3-letter word from these letters. Okay. I need words that have all the letters different. Okay. So I can't have like 3 S's and 2 T's and an S, right? I need all 3 letters to be different. I don't care about whether these words make sense. So to be honest with you, SAI, that's clearly not a word in English, but that's allowed in this context. I just need to pick 3 letters such that all the letters are different. Okay, so suggestions then. How many ways can I do that? So how many possible words can I make?
10 factorial.
Okay, so it's definitely factorial. Go on.
Divided by, we need to subtract same letters, like
Okay.
10 factorial divided by 3, 2, 3, 3, 2.
Okay, so why are you saying that? So 10 factorial, first of all, where does that come from?
Number of letters.
Okay, so 10 letters, good. Then you're dividing by?
We need to take the same letters. Yeah, like 3 S's we have.
Yes.
Then 3 factorial.
Yes.
Multiply by, we have 3 T's. Again 3 factorial, and then we have 2 I's, 2 factorial.
Okay, so this is close. It's not quite what we want though, but I just want to discuss this because this is useful. So this 10 factorial says how many different ways are there arranging these letters, right? This 3 factorial, and the reason why I'm dividing by it is because you don't want to, or you need to account for the fact that you have 3 S's. So all the arrangements where you swap all the S's over and you don't notice any difference, like if I swap all the S's over now, you're not going to notice any difference. Hence the reason why you divide by 3 factorial. Divide by 3 factorial for the 3 T's, again, you can swap those over. 2 factorial, because there's 2 factorial ways of arranging the 2 I's. If you swap those over, you're not going to worry about it. Now, what have you calculated here? You haven't calculated what we want, but you have calculated something else. I wonder if somebody else can help you out, maybe. What is it that you've actually calculated here?
You calculated the possible permutations of statistics.
Good.
Oh, the word, sorry.
Good, exactly. So not quite what we want. Go on.
So basically, you were looking at the types of 10-letter words you can make, basically.
Yes. Exactly right. So in other words, you take all of the letters and arrange them. This is the number of distinct arrangements that you can make. That's what you've calculated. Hence the reason why you've got the 10 factorial there. Remember, factorial means how many different ways can I arrange that many objects, in this case 10 letters. Okay? And the reason why you're dividing by those is because you've got repeats. So what you've calculated here, it could still be useful in some contexts, which is how many different words can you make from this, or how many different 10-letter words can you make from this, or how many different ways can you arrange the letters such that all the arrangements are different. That's what you've calculated over here. But it's not quite what we want. Okay? So, any other suggestions? How could we do this such that we get 3-letter words and all the letters are different?
Do we count one letter as a word?
Talk to me more.
It writes here how many words can be
Okay.
made. Like we can start with 1 letter, 2 letter, 3 letter, we can go like that.
No, so it has to be 3 letters in a word, okay?
3 letters?
So yeah, so I want, for example, SAI.
3 letter word, sorry.
Yeah?
I didn't see it. Yeah.
Okay, so these are all 3-letter words,
Okay,
right?
Okay. So we have 10 letters.
Uh-huh.
We need to take 3 of them.
Uh-huh. So how would you do that, first of all? Don't worry about the fact that we have repeated letters.
Yeah.
We want the letters different. How would you say, I have 10 objects and I want to pick 3 of them and make a word from them?
Combination, 10.
Sure it's a combination?
No.
If you want to put an arrangement, don't you?
For first one we have 10 options.
Okay.
Then for the second one, it changes.
Okay, good. So stick with it because I think you're along the right lines. Okay. You said combination, so 10C3. You start off with 10 letters and you choose 3 of them. That's not what we want here, though. What are we going to do instead? It's not a combination. It's a permutation, right? Because combination just says you pick them. You don't do anything with them, you just pick these 3 letters. Pick a group of these 3 letters. Permutation says I actually put them in an order. So in other words, if I pick the letters S, A and I would say with a combination, that's just a choose. That's just a group that I'm choosing. But with a permutation, I'm saying this is different to this, is different to this,
Yeah.
is different to this, etc, etc, etc. Okay, so with a permutation I take into account all the different arrangements of those 3 objects that I can have. With a combination I think these are all the same. Okay, now this is closer to what we've got to this. Okay, so this we've said was how many different ways can we get different arrangements of this such that they're all different arrangements. This is getting closer in the sense that we've now got 3-letter words. However, we have same letters included in this. So how can we adapt this, or maybe work with that, to get closer to what we want? We want 3-letter words such that all the letters are different. I can see a simple way of doing it.
Really?
Do we have to use all 10 letters?
No.
Why not just get rid of all the letters that are repeated? Yeah? So S, T, A, oh, that's another T, so get rid of that one. I, that's new, still got S, that's repeated, get rid of that. T, get rid of that. I, well, we've already got one of them. C is fine, but we've got another S there. So how many letters are we using? 5.
Not nice.
Really?
Too logical.
Too logical. But does it make sense how we got there?
Yeah.
It makes sense that you got the P, you got that yourself, right? You got the 10P3. Yeah. Then you say, well, actually, if I used all 10, I'm going to get repeats. So if I don't want repeats, get rid of all the letters that are repeated. I'm just left with 5 distinct letters. So 5P3 would be the way of doing it. Yeah. If you wanted to calculate this, your calculator may have a calculator button which does it. Otherwise, you could use 5 factorial over 5 minus 3 factorial, like so. Was it, sorry? 60.
60. Going.
Yeah.
Let's have a look at question 2 then. So similar kind of theme, but a different question. We've got a society. Now it's got to be made from 6 members, and we're told that we have a group of 8 women and 11 men. So let me just write this information down. There we go. Okay, so we need to make a society from 6 members. And we have 8 women and 11 men to choose from. Okay, so 19 people in total to choose from. How many different committees can be formed? Here's the crucial bit, such that there are more women than men. Okay, any suggestions? So we have to have 6 members in our committee. We have 8 women and 11 men to choose from. How many different ways can we do that such that we have more women than men?
We need 1 woman. It can be 4 women, 2 men.
Perfect. So let's just list all the different combinations that we can have such that we have more women than men, okay? I wouldn't start there, I'd start in a more logical place. All women, right?
Okay.
Yeah, so all women, so 6 women and 0 men, okay? What else can we have?
5 women, 1 man.
Okay.
4 women, 2 men. And that's it.
And that's it, because 3 and 3 would be the same, which is not what we want. So there's 3 different outcomes that we can list, okay? So this one, or this one. Now let's go through and think about how we actually calculate each of these different scenarios. So, if I want 6 women, if I just say to you, look, there are 8 women in total, and I'm selecting 6 women to form this committee, how would I do that?
Use combination.
Why is it a combination, not permutation?
Because picking people. It's not a warning, right?
Yeah.
Perfect. Yeah, there's no order associated. I'm not putting them into particular positions. So, for example, like Brenda becomes the secretary, Tracy becomes the president, and such like that. So they're not going into particular positions. I'm just saying I am choosing 6 women from that group of 8. Okay, I don't care about what positions they're going into. So, absolutely, I start off with 8, and I choose 6 of them. Okay. Just for consistency, how many different ways are there of choosing 0 men from a group of 11?
1 way.
There's just one way, perfect. So I'd write that as 11C0, which you're absolutely right is 1. What would I do with these two numbers? Because these are just numbers when I calculate them. How would I combine them together?
Time.
Good. Why is it at times?
Don't know how to explain.
Okay, so think about your laws of probability. That's fine. Think about your laws of probability. We say that there are two particular keywords that we're looking for. An and, which is that they both happen, and an or, which means that one happens or the other one happens. They can't both happen at the same time. The way which we combine the probabilities for both of these events then, for and, we end up multiplying the probabilities, and for or, we end up adding the probabilities. So you can go back and you can see one of my other videos where I actually talk through that in a little bit more detail. But effectively, that's what it boils down to. So in this case, we want 6 women and 0 men, which is why we have a times in the middle. And in fact, it's going to be the same for each of them. Okay? So the next one, are you happy, would be 8, choose 5, multiply by 11, choose 1, because we're choosing 5 women from the group of 8, and we're choosing 1 man from the group of 11. And the last situation we could have is that we have 8 women, we choose 4 of them, and we have 11 men, and we choose 2 of them. Okay? How are we going to combine each of these situations together?
Adding.
Adding, good, because it's an or. We can't have them both happening. We can't have them all happening simultaneously, right? So we're going to take this, add this, see what we get. Okay, so over to you. Do you want to stick that into a calculator? See how you get on. Okay, 4,494 different societies can be made, which is quite a lot. Good. Are there any questions about that? No? All makes sense?
I don't have.
Good. Perfect. All right, let's have a look at the last one then. So question 3 says, a bike lock is locked using a 6-digit combination lock. There are 10 possible digits for each of the 6 positions. A thief tries to steal the lock and he's going to try a code at random. What is the probability that the thief gets the code correct? Gets the code correct on that first attempt that they try? Okay. So how are we going to calculate it first of all? Just think about the probability side of things. What do we need? How are we going to calculate that particular probability there?
We have 6 digits.
Okay.
We have 6 blanks.
Okay, good. So I'll write this up here. So 1, 2, 3, 4, 5, 6. There's 6 possible.
And for every digit,
yes.
we have 10 possibilities.
Good. So there's 10 which can go here.
Yeah.
10 here, 10 here, 10 here, 10 here, and 10 here. So that's not the digits. That's kind of the number of digits that can go in each position. Good.
And we need to multiply them.
Perfect. Why do we need to multiply?
Because there is one true value for first digit and they need to be at the same time.
Good.
Yes or
Yeah, perfect. So they're all simultaneous, right?
Yeah.
So you're basically saying for every 10 that goes here, there's another 10 that goes here. So there's got to be 100 for the first 2. And then for every 100 possible combinations here, there's another 10 there. Hence the reason why you keep multiplying. Perfect. So you're happy? This is just going to be 10 to the power 6. I'll just write that as 10 to the power 6 actually, rather than a million, right? Okay, so what am I going to do with that number? How am I going to work out the probability that the thief gets the code correct on that first term? Good. That's the total number of codes that he's got to try, okay? And you're basically saying the first code has got to be correct. So that's 1 out of a million. Right? And you can convert that to a decimal if you want. It's not that hard. It'd be 0.000001, right? I think. Yeah, so that's the probability, right?
Yeah.
So either that one or that one. If you wanted a percentage, I mean, there's not really much point, but it would be 0.0001, isn't it? Percent? Like so? I think. Yeah. Okay, so either one of those forms is totally fine.